So, PRs this week. The only new one that I saw was from me. This is not really performance yet, but we'll get there, I think. I'm going through and refactoring memstore a little bit. This includes the vector object from PetStore from a couple of years ago, which no longer appears to be faster than bufferlist, which is great because bufferlist was awful before. It was notably slower. And I think a lot of the work that Radic has done over the last couple of years has basically made it as fast, if not maybe slightly faster than the thing I did. So that's great. Beyond that, it's just really pulling stuff apart a little bit to make it so that it's easier to change things in it. I'm probably going to try to figure out why memstore appears to actually be significantly less efficient in the write path than bluestore, which is kind of interesting. But that also seems to be somewhat true for. Well, actually, no, I take that back. I thought it was true for ScienceStore as well, but I don't think so. It looks like we're actually pretty good on the right path there. So anyway, that's that. What else? Closed stuff. Radic made a really clever change that allows Alien Store to use any classic object store rather than just BlueStore. So now we can run memstore and Alien Store, or I guess maybe file store. So that merged. Kifu merged that. This little PR from me that sets the OSD client message cap to 256. That looked reasonable in testing, so we just changed it. I think that fixes something that people were seeing related to heartbeat timeouts in production. This AVX 512 erasure coding implementation has been closed by the author. They no longer have the ability to test it, apparently, or update the PR. So I don't know how much we actually care about it, but that got closed. Updated. There's this pglog acceptable rollback info trim 2 PR. Kifu reviewed it. He wants Sam to take a look. Niha, I threw you as a reviewer on that as well.
Yeah, I saw that one come in. Those are a little tricky, so I want to spend a little more time to understand, if it's going to be detrimental in some way. In general, it looks fine, harmless, but just want to spend some more time there.
Yeah, I don't think it passed tests, so there's that too.
I thought it broke something, and Kifu pushed an additional change after that, so maybe it needed a change in the tests as well.
Okay. All right, let's see. RW tracing, Matt and else I don't know has been reviewing that. Looks like it's actively being discussed though, so that's good. This carriage handling optimization in bufferless C-string by Radic. Kifu reviewed it. Ilya had a couple nits, but otherwise maybe that looks good. Finisher, kind of basically giving up CPU automatically, an optimization there. Kifu and Casey are reviewing it. It's under kind of active discussion what that should be exactly, how much it should give up, how much concurrency should be allowed. So there's that. This optimized Ceph message header 2 decoding that failed testing. I think there's a question now from Ilya as to whether or not that's actually still needed, given another PR from Radic. This time to live cache implementation for the manager, that thing continues to be updated. I don't know what all the updates actually have been, but it's been actively worked on. Igor's PG removal PR, Kifu is doing more review on that. I think it maybe passed testing at one point, but he must have seen a couple of things that he wanted to talk about. I think that's all we've got for this week. Still a bunch of other random stuff in the no movement pile. Uh, I don't think anything real relevant to talk about today. Eber's not here, so and nor is Adam. So I guess none of the oh no trim stuff. But all right. So let's move on. Unless there's any PRs I missed, guys. All right, Sage, did you want to introduce this SMR status stuff?
Yeah. This is an email conversation that sort of got kicked off a couple weeks ago, but we didn't really follow up. And so mostly just wanted to talk to Glebe and find out what the current status of the SMR implementation in BlueStore is, and what's remaining, and what the path forward is. So I know a whole bunch of work merged last year that I'd missed because I was out. So I haven't reviewed it. I'm not really sure exactly what it does and doesn't do yet. So I'm just curious on where we're at and what we need to do to get to the finish line.
Okay. Can you hear me?
Yep.
Yeah. Okay. So yeah, I've been working on it by myself. I had one student helping me a little bit, but that was a master's student, so he's gone. So I've been working on it on and off, and Igor was reviewing the patch test. So a bunch of stuff that I did originally, I had to redo it based on Igor's feedback. So the status now is, so the one annoying thing is I work on it for a while, and then I come back, I rebuild stuff is not working because some change broke stuff. So I go and try to find what caused that and fix it again and then continue. And right now I'm in one of those stages again. The nice thing is the change that broke it, I figured out the commit, and there's just, I comment out one line and it works again. Anyway, what's remaining is, so last we were discussing with Igor how to so we were storing, for every object, we were storing metadata in RuxDB. The way we store it is there's a separate namespace, and in that namespace we have the keys, where the keys are the zone number and the object ID appended to each other. And the value is the offset of the object within the zone. And whenever we, let's say, add a new object to a zone, whenever we write a new object to a zone, we create one such entry. Whenever we delete an object, we delete this key value record. And whenever we update the object, let's say either by writing to the same zone at a later offset, we update this. And this way, when it's time to clean, we query that namespace with just the zone name, and that gives us the OIDs of all the objects within that zone, and the values are the offsets. So I originally implemented it like this, and then we were discussing with Igor that so to read an object, now we have come to this cleaning stage where we need to read the objects from the zones and copy them somewhere else. And the problem there is when you read the object, when you read the OID, you cannot read the object just from the OID. You also need the collection ID. So, and then we thought about storing the collection ID as well, but then you cannot store collection ID because the objects may split. The collections may split and merge. So CID become. Our knowledge, our understanding of CIDs is a bit vague. We tried to understand the code, and then we weren't sure how to do it. In the last comment, Igor proposed an idea about how to do this, but I haven't read through and thought it through.
Yeah,
But that's where.
I think it's the GH object ID includes the pool. You basically need the pool identifier, and you need to know the erasure coding shard. I think are the two things, and that should be enough. And then the collection is really just like a subset of the pool ID and that. So
do you think storing just OID is enough for retrieving the object?
I have to double check. I think you need the pool ID and you need the shard, but I can't remember if that's part of the GH object or not, object type or not.
Yeah. So that's where we are in terms of
Okay.
and then what's another thing that so the next step after that is to implement do move, which like similar to do read, the do move that atomically moves an object from somewhere its current location to somewhere else. So that do move needs to be implemented, and then after that, implementing we already have the logic in place to consistently clean a zone. After that, that waits for do move to be implemented. Once do move is implemented, I think it's my ultimate commit where I specify how to do that. So the after that we have a complete assuming all the bugs are fixed, we have a basic working
system.
Working system. So right now we can write data to SMR disks. We can shut down the system. We can start and read the stuff that we have written. But we need to come to the what metadata we need to persist, and then implement do move. Those are two key things left to get the basic things working. Okay. And then the fun part for us starts, which is there are many design decisions, and I'll be exploring with the new student that comes in how to there are many design decisions about the space allocation and object placement and so on. What the policies. So once we have this basic thing working, then we can start having fun with it. But in your if you assuming you're actually targeting with this really large object, given that people who use SMR will store on them really large objects, people may get things work. It may be used because the zone size is 256 megabytes. So if you store gigabyte-sized objects on it, then you don't even need cleaning.
I think they won't be that big though. At the Rados level, the objects are going to be tens of megabytes at most, probably depending on.
I forgot about that. You still, even if the user writes gigabyte objects, you still need to chunk it. Store smaller Rados objects. So that's where the status is.
Okay.
I think it would be. I don't know what's the I think it would be nice if. I was busy with a bunch of other real life stuff. So I'll resume working on it next week, and I will have students working on it as well. I think if someone, Igor is responsive, but sometimes it takes a couple of pokings to get a response from him, and also because since I've been working on it sporadically. I would do some commit, and then a couple of weeks or 3 weeks would pass, and then I would ping Igor to give me feedback. And he also, since he does a thorough job, he needs to bring everything into cache to remember where things are. So it takes time as well from him. So I hope if Igor is nice, but maybe someone else, if someone else could also give review the PRs. That would help.
I have a couple quick questions about the status. So all of the BlueFS stuff is already done, right? Is that all? All that's in tree?
No, so the BlueFS stuff, actually none of it is done because what we did here is we just, since SMR drives have
We just put it in the CMR version or the range or whatever.
random write region, which is like
Okay.
500 something zones, which is pretty huge. So the current code just writes the RuxDB into that region.
I see. Okay.
But that SMR stuff, I mean the BlueFS stuff, that can also be integrated. But yeah, I just thought that's a solved thing, and given that we have this zone, I just try to get the SMR part, because this part is the more complicated part, working immediately.
Yeah. Okay. And I imagine that we could probably avoid doing the complicated part of the RuxDB with the log file append stuff working, because that part, the log files that we're appending to with small writes, could always go in the
conventional
conventional zone. Yeah. And then only the SSTs go in the SMR region.
Yes.
And that should be plenty. Okay.
I mean, right now, I can specify RuxDB as I can specify a single SMR drive as the whole drive, and yeah, I needed to actually check it. I don't remember exactly, but basically, there is a few gigabytes of space where you can write, you can do random writes, and all the RuxDB, I actually pre-allocate. Yeah, when I start allocating, I just preserve that whole region for RuxDB, and then start allocating actual data from the SMR region.
Yeah. Okay. Okay, that makes sense. I have a couple questions about the reverse index they were talking about. So if I remember correctly, you said it's basically a tuple of the zone identifier and the object ID and the index. Is that like the offset within the index?
Yeah, the key is zone ID plus a concatenation of zone ID and the OID, and the value is the offset within the zone.
Okay.
So
basically, when you're updating that, you basically look at the entire object and you look at the set of all the zones that it touches, and then you make sure that one key exists for each of those. Is that the idea?
When we update the object, can you repeat the question?
Yeah. So if you're doing a write, basically the first time that you write any part of that object in a new zone, then you insert the key, and the last time you remove a piece of that object from a zone, then you remove the key.
So the assumption is we write the whole object into zones.
Yeah.
Yeah. So
right, but you might have you might append to an object later or make an update to an object or whatever, and so you basically the right path would basically at the very end it would say, do we touch a new zone, and if so, add the key, and did we remove a reference to a zone and then remove the key?
Okay, so I think our assumption was our assumption was like the RGW workload where you have complete zones and you do not have update to zones. So you write complete zones and you delete. You write complete objects, you delete complete objects. Yeah, and in that case, you can only either overwrite the object, or you can delete the object, or you can write a new object.
Okay. Okay. Because I'm just wondering if it might make sense to have a slightly different key structure. Because I guess the downside to this key structure is that when you are doing the cleaning, the all these keys in the zone are going to be like randomly ordered based on where they're actually located in the zone.
Yes, like the keys yeah, so when cleaning, you'll just query by the zone number in the namespace, and that will give you the list of objects.
Yeah, but the
A
objects
list
will
of
be in random
IDs.
order. The objects will
Yes.
be in random order effectively. So I'm just like thinking out loud here. One alternate approach. I don't know if you have the pad open, you might want to open the pad because you can take the chat. Because an alternate key structure might be zone and then zone offset. Map that to object ID.
So are you writing here somewhere? I don't see anything.
Yeah, in the chat, in the Blue Jeans chat, I put a link to the Etherpad.
Yeah, I opened the pad.
Oh yeah, if you go down to line 90-ish.
90. Okay, now I see.
So then if you did that, then it would order by zone offset, which would make for efficient cleaning, right? Because you could just read these sort of sequentially. But the con is that you'd have a AV pair per blob, any per object, right? Whereas the pro here is that there's one key per object zone. I wonder if there's like a hybrid approach where we could do. Like,
Okay, I see. So you're saying zone and zone offset and object.
Offset and object ID. That would be an alternative. Would be this, right?
So
I don't know.
when you say efficient cleaning, why is
so when you clean, you have to basically read everything, all the live data that's still in the zone, you have to read out of the zone and then write it somewhere else. So writes are easy because they're always sequential. You can just allocate them sequentially, but the reads are expensive because you actually have to seek.
Okay, so you're trying to avoid seeks when reading the complete zone.
Yeah, so the cleaning, we don't want the clean to like have to do a whole bunch of random IO within the zone before it'll work.
Yeah. Yeah, I don't know what I originally had there, but because this is like this current scheme. I originally had something else. I don't remember. I need to check. This one, Igor suggested this one, and okay. I think it's. Okay. So I think the with this one is with that one, when you have objects, you can just read the object ID and read the complete object. With this one, you have the offset. You need to you have the object ID as the value. Okay. Okay, so yeah, it's pretty much the same thing in terms of, except this one gives you a sequential read of objects.
Yeah.
Oh, what's this third one? Original zone offset object ID. What do you mean by original zone offset?
The very first time we wrote some data for that object into that zone. I guess so. The problem with the second one is that you would need a new one of these every time you have a different extent in the zone that has data for that object, and so there might be multiple, and so you'd just have more metadata, more keys to deal with. That's a cost. But we don't really care about all the different offsets necessarily. We just care that this object is in that zone somewhere. And if the ordering isn't perfect when we do our cleaning, it's still better than totally unordered. And so this third one is sort of like a hybrid. Like the first time we touch a zone with a particular object, we record that offset. And most of the time that's going to be all of the object or most of it or whatever. And so if we went just by that, then we would get mostly sequential I/O during cleaning, but fewer keys. One key per object per zone. Anyway.
So, are you, so again, our assumption was write once object. So you just, are you also changing that?
Well, I think we need to make BlueStore work. It needs to be fully functional, regardless of what the I/O pattern is. It just doesn't have to be efficient in that case, right? So we can say you shouldn't use SMR drives for random block I/O, right? But if you have an existing object and you overwrite the middle of it, we don't want the OC to like return an error. It needs to still do it, even if it's inefficient.
I mean, okay, if you want to support like a general case, then yeah, this we may need to rethink. We actually haven't. I personally haven't thought about the general case where you can have random overwrite of an. I mean, not random overwrite, like overwrite, partial overwrite, or extending, appending an object, and so on. So I think you're trying to address all those cases, right?
Yeah. Well, I mean, my suspicion is that all the existing BlueStore code like already deals with all that complexity. And so it shouldn't really be more work, as long as, yeah, I don't think it'll, in fact, it would probably be more code to write to make it not work.
No, it's only about yeah, I think the only thing is the assumptions that we made about, so the assumptions we made, I made, was a single object. First, we like the simplest possible case, which is you can write complete objects within a zone. You can overwrite a complete object, which means just writing the same object with new content somewhere else. Or you can delete an object. And some further assumptions are an object may not, will only live within a single zone. Like it may not be partially, like if it's, let's say, you're at the end of the, it does not like live partially in this zone and and then partially zone. So if we are considering a general case, then probably, which would be nice. I'm just, again, this was originally just to get something working so that I could get the performance numbers. Then we can think about how to do better indexing that support all those cases. So
okay. Well, maybe the thing to do is I can spend some time and just look at the current code and see what how it was implemented. Because I think if you were designing something from scratch, those simplifications would make a lot of sense. It would make everything much simpler. But we already have all the infrastructure for having tons of different extents within an object, all these different blogs and all the checksums associated with them, all that, and for allocating and deallocating, doing partial overwrites and stuff, like all that stuff already exists. And so I think making something that only supported the simple cases you're talking about would mean somehow bypassing all of that other code. But I think it would actually be harder. I think it would actually be harder to implement what you're saying, basically, than to do.
Sure, it's. I think the only. I mean, I didn't have a really good understanding of all the currently you have like extents and like a couple of layers of things. Okay.
Yeah.
That's why I kind of targeted. So yeah, if you spend the time on, if you think about how and then how you can design it better and also explain it to me, yeah, that would be
Okay. Does so there's an allocator. There's an allocator implementation that's in there? There's like an
yeah,
SMR
the
allocator or
allocator,
something.
yeah, it's all of them are rudimentary allocator and the free list manager. It's
Okay.
the allocator just sequentially allocates stuff starting from some beginning zone
Yep.
and goes on like this. Like
Yeah.
we do not handle the cases of let's say when the disk is full because that relies on implementing garbage collection. Yeah, so it's there's an allocator there. There's an allocator and a free list manager. So for each zone, we're tracking the number of dead bytes within a zone and the offset, the current write pointer. We're
Got it.
tracking
Okay.
two things, and every time we allocate something, the allocator allocates something. Those two things are updated. I mean, the allocator only updates it when it allocates new space. It's mostly write pointer, but then whenever we delete object, we increment the number of dead bytes within the zone.
Yeah. Got it. Okay.
And then the cleaner does a sort on the current zones based on the number of dead bytes and selects the zone with the most dead bytes, basically greedy cleaning at this point. That's there. I mean, it's not a lot of code.
Yeah.
I think you can just spend a few hours to go through it.
Yeah.
And
Okay. Okay. Cool. Sounds great. And then I guess there was a related discussion on that thread about actual SMR hardware.
yeah,
I guess
so
yeah.
then the reason I wanted that is at least like if we could have like it on a small cluster, just for making sure that. So right now there are two breakages that I still haven't debugged. I was just discussing one with Kefu. Basically, what happens is people add code and they do not. If the SMR code was being actually tested in the test servers, they would see the code breaks and they would fix it. But right now, since it's not being tested, they just keep adding code and it breaks, and then I have to figure out how to fix it. I mean, I think it's between you and Matthias had to decide how to do that. But I think the sooner you have at least a few for the test servers, and until just to avoid the code rot.
Mark, are there any of the like smaller subsets of machines that have empty drive bays that we could put SMR disks in?
Not really. I mean, in Certa, we could maybe take out some of the existing drives to add them in. But I don't know of any other machines that have like you're talking 3 1/4 or 3.5 inch drive bays.
Yeah,
right?
These are like normal. Yeah.
Yeah. Yeah. I don't know of any others that have them. I think Insert is the only thing that we've got that isn't the performance side of things. Otherwise, Smithy. I mean, they've got like 4, 3
or maybe the Gibba. Since there are fewer Gibba, we could do like if we did all the Gibba, then we would have a uniform set of machines that we could test on. That might be the way to do it.
Okay. Yeah, I don't even know what those are. I don't know what they have.
They're like They're like slightly newer Smithy.
Oh, okay.
Do you remember how many Gibba we have, Josh? Yeah, I forget.
Yeah, there's a wiki page. Just give me a second. I'll pull it up.
Looks like there are like 45 of them. So that might be the way to do it. That's a more modest number of drives to get, and then we could run an actual test suite on it on a regular basis. If we did like Rados/SMR or something like that. Yeah, I mean, I think so. There are some there's some unit tests for Blue Store. Like there's that run that do a whole bunch of like super obnoxious tests. If we could make those work with like a simulated environment, um, that'd be pretty valuable because they're doing like all these like these torture tests with like allocation, randomly allocating and deallocating stuff and overwrites and whatever. Like if we could set up one of the simulated SMR
So
drivers or whatever.
the way I test it, every time I make a change is I build vstart and then start a small cluster and then create a pool and then do write of objects for 100 seconds. That's how I test it. So if something like this and whatever code people are adding is breaking that, okay, that test sequence that I just described. So if there's you have a unit test that does something like that, which is pretty basic, not a torture test, then those would be visible to the developers. So, and actually we do not need to have the kind of failures that I'm seeing. They can be detected using just the emulated SMR drive that can be created in memory. And when I'm running my tests, I'm actually patching Ceph to use like only the first 100 zones so that I could trigger garbage collection. So you can just create a emulated drive in RAM and then use that. But yeah, we do not need to actually insert disks. That would be good enough until things start working.
Until it starts working, and then we could go get a bunch of drives. Yeah. Okay.
Yeah.
Do you know, a separate question, do you know what the current like size bonus or whatever for SMR versus conventional drives is? Like how much bigger / cheaper are the SMR drives compared to the conventional ones? Whether it's like maximum size or price per gigabyte or whatever.
I think it's 10%, with the Western Digital drives. Like they have Ultrastar drives that are, let's say, yeah, I think we can look it up. But what they're saying is with they're moving towards this higher MAMR technology, and there it's going to be much larger difference. And then the other thing is, if we get, that's what I'm actually planning to also research. Once we get, I know you target ZNS drives with your new backend, but if we get SMR working, we can just plug ZNS SSDs and it will work as well. And some of those ZNS SSDs are actually targeted for QLC flash. Most of it actually, primarily QLC, which is high capacity. So there will be there are plans to make like enterprise ZNS SSDs that are also low latency, very fast, and so on. But primarily it's for QLC, which I think will still find a use in BlueStore. Like even though once we have the SMR working, you just need to like put ZNS SSDs and it will work.
Yep. Okay.
So it may be much faster to support. Yeah. So basically, when you say you target early 2020, 2022, it's not just if we get this working, you will not have support just for SMR. You'll also have support for ZNS SSDs.
With BlueStar, yeah.
Yeah, with BlueStar.
Yeah.
And one other thing that they've mentioned. So right now we have added this libzbd, and like the Western Digital folks said that ZNS SMR zone storage support is within the kernel. We do not need any libraries. We should get rid of ZBD, and the kernel provides ioctls to issue So we do not need an external library. That's another to-do item, basically, to get rid of libzbd.
Yep. Yeah. Okay. All right. Cool. Niha, Josh, anybody else, any other questions?
No questions. I just added the object store tests that we have that do a whole bunch of simulation that Sage was talking about. So you can take a look at that for some examples already. But yeah, this sounds good.
Yep.
Yeah,
if we can get
that's going to be able to support DNS in addition to the smart drives. That's fantastic.
Yep. I think if we could get the as the like a wrapper script that last time I checked, basically to get the emulation set up, it's a kernel device. Like it's like a kernel loopback, and then you set up this other, I can't quite remember, but it's basically have to set up a kernel block device to do the emulated SMR stuff. So if we make like a bash script that sets all that up and then run store tests to like consume that simulated device, that would be the way to do it. Filter, whatever. We have to figure out how to. Yeah.
I mean, I think it's a single line to create an SMR drive. The email thread in the I think the email thread Damien described how to do it. Yeah. So there are three options, but I think the easiest one is just the one that creates an in-memory SMR drive. Right. So you may want to use a few hundred zones, which will take about, I don't know, as much RAM as, 1 gig drive should be enough with 4 zones for the basic tests, just to make sure that the edit code is not breaking things.
Cool. Okay. All right. Sounds good.
Okay, so I think you're going to take a look at the code and then.
I think the next step is for me to read the code and see what the next steps looks like. Where to go?
Yeah. If you come up, then we can discuss what to implement. And then I don't know. Are you going to be reviewing the PRs? Will you have time for that, or?
I'm guessing yes, but let me start by reading the code and just see where we're at, and then.
Okay.
Would it make sense to do some sort of code walkthrough of what we already have and where we are?
I can do that. It's again, it's not a large amount, but I can do that in very quickly. If you guys want next week.
Yeah, let's start that. Yeah, let's start with that. Yeah.
Okay, I'll do that next week then. So is this recording?
Awesome, thanks.
Yeah,
yep. Yeah. All right, we'll follow up with on the email thread.
Okay.
All
right, cool. Only other thing I had, although I think most of the people here are from the core meeting, so it's just the stuff from there. I linked it in the Etherpad. The Crimson/Classic performance and efficiency comparison stuff. So for folks that weren't in the core meeting, this is basically just looking at how we're doing right now. Radek had expressed some concern that we weren't really showcasing Crimson's benefits as much as we could have been by doing really large data set sizes, whereas he thought that smaller data sets would show it off better. And that's not exactly, it's probably true in the test that he ran with Rados Bench. In FIO RBD tests, I think it's less so, possibly due to PG lock contention when you have really small data sets with RBD. But in any event, I ran a bunch of tests. And if you look at the results there in the linked spreadsheet, the gist of it is that for reads, random reads, small random reads, Science Stores is quite efficient. But for Alien Store and also especially on the right path, Blue Store is actually more efficient in some cases, or at the very least very close to as efficient. It's not the kind of the big takeaway from that one is that memstore for some reason is quite a bit less efficient on the write path. So it's probably worth looking into that and figuring it out. But interesting data here. Hopefully we'll kind of figure out why Alien Store and Blue Store on the read path, specifically Alien Store, kind of up as the dataset size grows. But well, in any event, lots more to do. Maybe I'll talk more about it next week. Maybe we can get Radek here too, because he has opinions on a lot of this too. That's it. All right. Anyone else have anything this week that they want to talk about before we wrap up? All right, then. Have a great week, guys. See you next week.
Thanks, everyone.
Thanks. See you.
Bye.
Thanks,
See you
Lee.
next week.
Bye.
See ya.